All right. Thank you for joining for the talk SQL Programming in Databricks. My name is Serge Rielau, and I am responsible for the SQL language API in the Databricks for the entire product.
Hi, my name is Milan, and I'm a software engineer working on Databricks SQL.
All right, let's get started. So we're going to talk about four major topics, one of them around sorting. I'm going to talk about shorthands, things that make your life easier dealing with SQL. We're going to talk about variables, and then Milan is going to close it off with this really exciting thing called scripting. So when we talk about sorting, of course, you all know the standard order by. That's not what I'm talking about here. What I'm talking about here is sorting about something that is a bit more complex, so something that's a bit more of a challenge. So in this case, for this talk, I figured I can do something like, let's try to sort an array of points by the distance from 0. Okay, like in a two-dimensional plane, the distance to 0. So for that, we need a custom sort order. Okay. And to use custom sort orders, we need to employ two pieces of SQL that are rather interesting. One of them is a lambda function, which we can use to define order. And then we use the array sort function, which actually does perform the sorting if I have an array. And then lastly, we want to do something to hide the complexity because it's going to get a bit messy. So let's start with lambda functions. Lambda functions are anonymous functions which take at least one or more named parameters, and they can be passed to a number of built-in functions. Typically, these are map and array functions. So they operate on each element of the array or on each value of the map. Okay, and if it's a single parameter, you can just have a p right arrow, and then you have an expression, which of course depends on p. Right? Or you can have a tuple, like some sort of P1 through Pn, and then that then is used with an expression which also depends on these multiple P's, P1 through Pn. Okay, so these expressions need to be simple. They cannot have subqueries. They cannot have SQL UDF, which I'm going to bring up later. And the result, of course, must comply with the expectation of the function that is going to use that lambda function, right? So in case of a quick sort, right, of an array sort, we have an expectation that if I have 2 points A and B is greater than 0, then that means that A is greater than B. Okay, so if the lambda function has a result that's greater than 0, that means A is greater than B. If it's equal 0, then A is equal B. If it's less than 0, then so standard quicksort semantics that you know from your CLib. Okay, so if I use a very simple one, just sorting some numbers, I get a select array sort of, in this case, I have a simple array with like some values, and I say, okay, A, B maps to A minus B. So if A is greater than B, then that all works out. Okay, yeah, leaving nulls out here to not blow up the demo. Okay, and that works 1, 2, 3, 5, 8. Okay, cool. Now, if we want to go and sort distances, things get a bit more complex, right? So, and we all know this is our old friend Pythagoras, and he basically says the length of this part of the triangle is equal to the square root of x squared plus y squared. So that's the distance from 0, okay? Now, we don't need the square root here because that doesn't change anything with respect to the order. So we can say that D1 is less than T2 if and only if x1 squared plus y1 squared is less than x2 squared plus y2 squared. Okay, so that's the formula we need to implement on our quicksort. So that basically defines our lambda function. So in this case again, select array sort. Now we have a table points. I didn't print this out here for purpose of space. And we have the P1, P2, 2 arguments, and then we have the same formula that we had before with the minus. Okay? And this works. You see 1, 1, minus 2, 0 is the next one, 3, 0 gets bigger, and then 6 minus 4 is the biggest one. Okay? So now we have a beautiful thing that sorted arrays using a complex formula with lambda functions, but it is ugly. really ugly. And we don't want to keep typing this in everywhere where we need this. So the idea is, could we use something to go and hide this complexity, make it a reusable asset? Okay. For that, we can use SQL UDFs. So SQL UDFs they come in two flavors. They can be scalar and table UDFs, and they're written in SQL. So unlike a normal UDF that you might have known in the past, which might be written in Scala or Python or whatever, so in this case, or Java, in this case, it's written in SQL itself, so it's native to the SQL language. It's a securable asset that is stored in Unity Catalog, so which means you can grant people access to it or not, it's your choice, and it can be recycled. It sits in a schema just like a view, for example. It supports name parameter invocation and defaulting. I'm not going to go into too much detail there, but the idea is that you can basically specify, assign your arguments to parameters by name, and you can also omit certain arguments by just defaulting them to a predefined value. Okay, so if it's a scalar, then they encapsulate an expression, which may include subqueries, so they might be quite complex, and they return a scalar value. Scalar can be a complex value, but it's still a scalar value, right? And they can be used in pretty much all the places where built-in functions go, with minor limitations, like for example in Lambda functions. There's also the table flavor, which basically encapsulates a subquery, a correlated subquery, because you have parameters, of course, that you take. So it's really a parameterized view. It's like a view, but it takes parameters. And this one can be, of course, used in the form clause. So now let's use this technology for our sorting. So we want a SQL UDF that does sorting by distance. So we have a create function, points sorts, that's how we're going to call it. And it takes a parameter named points, and that is defined as an array of a struct of x's and y's, of an array of points. Okay, and then it returns the array sort of this input argument. Now we can test this out again. This is the same query as before, just without all the mess. Select point, sort points as points, and there you go, the same result. So this works. Okay, so now we have made a reusable asset to do some complex sorting. So that's quite nice. Now, let's go into the first really exciting part of this thing. I'm very proud to announce that we are working on a feature called collation. So, and we are actually opening up for private preview very soon. So you can actually go and scan that QR code if you wish, or you can do this later as well. It's going to show up more times, or talk to your SA if you're interested. So what does collation mean? So it's a means to sort and compare strings according to complex sorting algorithms. And these complex sorting algorithms are typically things like a locale, right? Where you say, hey, I'm Greek. I need to have the Greek language, and I need to do sorting according to the rules of the Greek language, or Cyrillic, or Chinese, or whatever, right? So there's locale-specific sorting, but can also be things like case-insensitive, right, comparisons, and accent-insensitive, accents like umlauts and accents in French or so, okay? So, and the collation can be attached to a string type, which can be either during a query, which we're going to hear in the following slides, but also like when you create a table. When you create a table and you create a name column, for example, you can say, I want this name column to be a string, collate something, okay? And it's used in many string functions like lower, upper, substring, locate, like, and so on. So the vast majority of string functions support it. We are going to have support for by delta. We are going to have support by photon. So it's going to be supported throughout the entire stack. And of course, things like group by, order by, you can group names by these collations. Okay. So let's just go through an example here. So let's first start up with a default collation. So this is what you see today. If today you do a select of a name from some table, order by name, okay? And in this case, I have like some guys named Anthony's, and I have a couple of Berthas. One of them is uppercase, one of them is lowercase, and one of them has interesting accents on top of it, okay? And what you notice here is the capital A through Z comes before the lowercase a to Z, which comes before the umlauts. That's how it works in default ASCII collation because the ASCII characters are just organized this way, and we just sort them by the code points in ASCII, and after that it's just the normal UTF-8 that takes over, and that's where all these umlauts eventually show up in whatever order. Okay, so this isn't really what we want, and this is why we think the collation is a very useful feature. All right. So the first name I want to use is collate Unicode. So collate Unicode is what's called the root collation. So, and what you see then is when you use collate Unicode, you just take the you take the string expression and you just add collate and then the collation name to it. So collate Unicode, now you will see all the A's are together, followed by all the B's. So that is much more useful, right? So independent of the casing and of the accents, they are nicely grouped. So this is a root collation which has a decent sort order for most locales. I haven't specified anything about a locale here. Okay, so now the next one up, which was actually the one that caused us to actually implement this feature, was case insensitivity, and this is then called collate Unicode underscore CI, CI for case insensitive. And in this case, what I'm doing here is I'm trying to find all the names that start with an A. But I don't want to say all the ones that start with a lowercase a or with an uppercase a. I just say start with a, in this case a lowercase a. But because I said collate Unicode CI, I get both the lowercase Anthony as well as the uppercase Anthony, okay? So, but what we see here is, wait a minute, case insensitivity is not the same as accent insensitivity by the standard. Anthony with that little dash on top got lost. So for that we need to give one more crank at the handle. We need to do collate Unicode CI and AI, so case insensitive and accent insensitive. So now we have equality all the way from A to Z accent, and we can actually get all our Anthonys here together. And we are supporting hundreds of predefined collations. So these are predefined names, and you can go and combine, for example, case sensitive, accent sensitive with your locale, if you're French or German or Serbian or whatever, right? So you can go and say, I want this according to, for example, German phone book collation. You can do this. Okay. Now, let's talk about shorthands. So these are like productivity features. And there's really two of them I want to talk about. So one of them is the group by and the order by. And when you look at this, this is like pretty humble beginning. It only goes pretty far back. So what you see here on the screen is pretty normal, right? So I have a query here, and it does a grouping. It has a pile of employees, and it sums up hours and pay. If they're paid by hour, and then yeah. So, and what you see here is that both in the group by and the order by, we have repeated most of the columns in the select list, which is really annoying. It's easy to mistype, and it basically just makes work, right? So what the SQL standard did early on was kind of like recognizing this and said, okay, fine, we don't make you actually type out the expressions. For order by, we allow you to just give the column positions, right? So you can say order by 1, 2, 3, and then pretty soon people realize this makes also sense for group by, so they're all out for the group by. So you can do this 1, 2, 3, 4, which is still annoying because you can still miscount, right? And it's kind of like, it really looks stupid. So is that the best we can do? And we can definitely do better than that. So the idea here is to just say, Databricks, just do what you know I want to do, right? So the expectation is when you do a group by all the columns in the select list which are not aggregated. That's obvious, right? I mean, it doesn't really need a rocket scientist to figure this one out. And when you do an order by, just order by all the columns from left to right, using default ascending order, or at least enough of them to guarantee uniqueness, right? So you can be smart about it and drop stuff in the end, but just do the right thing. So let Databricks figure it out, and then this whole thing collapses to just group by all and order by all. Okay, so this is much better. So now, let me talk about another one which I actually like even more than this. So this is very handy and also pretty common. But select star is one that is really underappreciated, as I found out. So select star has always been the bad boy of SQL, right? There's actually, we should never have done select star. It's the wrong thing, should never be in the standards, right? What if the schema changes? What if no one knows what the SQL is doing? I don't know the columns, right? So everyone hates it, but everyone uses it. So why is that the case? The reason why that is the case, I think, is rooted in history. Because in history, when you had like an OLTP system, you're running on the mainframe, you're in a bank, you don't want anything to change. The schema never changes, right? Don't change the schema. It's all very tightly controlled, right? But in the lakehouse, schema evolution is expected. We have schema chaos. We want to evolve it. We want to make our life easier. A lot more stuff is ad hoc. So kind of like the role has changed, right? So now in the early days, like select star as it is defined, is okay when you just say select star, it just takes anything from the form class and groups and picks it up, right? All the columns in the form class. You can also qualify it with a table name, then it will pick up all the columns from a specific table in the form class. Okay, you can change that too. And pretty soon people realize, well, sometimes I just want some of the columns or most of the columns. They say, well, select star except for these two columns. These I don't want, but everything else I want. Okay, so that is pretty normal. You can also exclude fields from a struct. You can pick out individual fields and say, I want to suppress that. But now let's make this a little bit more interesting. So let's take select star off the leash. So the first thing I want to do, I actually want to flatten a struct. So I want to go, in this case here, we have a person, Wile E. Coyote, okay, and he has a street address, and the street address is in the struct, okay, street, city, zip. Okay, now I say I want to unnest that struct, but I don't really want to talk about all these things. I want to say, okay, fine. So I know the struct is address, so I say select star except address, so pick up all the normal columns, and then address.star gets me into the field, extracts them all as columns, and of course, but in this case also just to make it more fun, I said I don't actually want a street, I just want a city in the zip. All right, I want to make it a bit more coarse, and that works fine. So this is already quite nice. Now let's see if we can like do the reverse of this. What if I have a pile of columns, very flat, and I say, hey, I want to return this, but I want to turn some pieces into a struct. So again, we have Wile E. Coyote, this time is all flattened out. And we say, okay, fine, name, the first and last name we're going to take as is, but the rest of the columns, except name and first name, we want to turn into a struct. So I can actually do that. I can use the struct constructor and just drop star into it, and it will just pick up all the columns and make me a struct. And it will pick up the names of the columns and turn them into field names. So you see here then, you see Wile E. Coyote, and you have your street, the city, everything is nicely picked up. Very convenient. If someone adds a file, if someone adds a field later, it will be automatically picked up. Thank you, thank you, thank you. I didn't do it, it was already there. I'm just saying it as it is. So, okay. Another one we can do is we can also do this, for example, on the array constructor. We can go and we can pick up a pile of columns and basically transpose them into an array, right? So in this case, again, we have contact information for the Coyote, and we pick up the mobile and the home number, and we just turn it into a pile of phone numbers. So that's quite nice. Finally, we can go and we can pretty print. So we can actually go and take Wile E. Coyote again, and we can say, hey, just give me this as a comma-separated string. So, and there it is. You just say concat underscore WS with separator, I think, right? And say we want the comma as a separator, comma space, and then just slap on the star, and it will go and it will serialize your entire row. Quite neat. So the story here is this. You can use star pretty much anywhere where you have an argument list. This is really interesting for these n-ary ones, where you have a variable number of arguments, right? So for example, least, greatest, coalesce. Find me the first column that is not null in the row. That can be handy. And you can also use it with UDFs, for example, right? They're not n-ary. You can even, and that's new, and for that I take credit, I think it's since 15.2 or 15.1, you can even put it into the where clause. So you can find a value anywhere in a column of a table. New topic, variables. One of my favorite. So a while ago we introduced name parameters and unnamed parameters. I'm going to focus on name parameters here because it's interesting from a DB SQL point of view. That's a fairly new feature. So in the past, when you wanted to use widgets, you had these mustache thingies, and it did text substitution, which is not very nice. So instead, what you do is, if you use the colon syntax, which is the ANSI standard way of passing parameters, you can use a uniquely named placeholder for any typed literal. Okay, and typed literal doesn't have to be a string; can be anything. Okay, and it's safe from SQL injection. You're not going to do text substitution. We're actually passing in this literal as a literal, so we know what it is. The widget will, the notebook will automatically pick up that colon name pattern and generate a widget out of this, allow you to pick the type, okay, so you can adjust the type, and then you can input the right value. And you can reference this thing pretty much anywhere in your notebook, and it will always go and put in the right thing. So now this does have a limitation, and the limitation is I have to type in the widget value. I can't really go and like use SQL to fill in the widget value. So that's a bit of a problem. So I would really like to have proper variables where I can go and pass something through. So let's take a look at that. That is a new feature that was added not too long ago. It's called session variables. And session variables allow you to flow data throughout a session. So they are declarative, so which means you define them with a type. You can even give them a default. There is a long form, proper SQL syntax, declare variable name, string, default, and then you can put in an expression. Or there is a short form for people who are not that eager to type that much and can just say declare variable is implied, name equals Anthony, and there you go. You have just declared a variable. The type was inherited. It's a string because that's what you gave for default, okay? And you can reference them pretty much anywhere where a literal can go. So you can say select star from names again, where name equals session.name, call it Unicode CI, and there come out your Anthony's again, okay? Now, that would just be a name parameter now again, right? But we can actually set them. And please forgive me for having to say set var. I have not figured out how to do this in the grammar without. Thank the people who did high variables. So, so you can go and you can set a variable, and there is your SQL on the right-hand side. So you can run a piece of SQL and put the value in here. You can also set more than one variable at a time. So you can actually select a row from a complex query and then assign that, right? Which may be based on a widget in this case, like this colon ID. Okay, you can even reset a variable to the default without having to remember what the default was. Just say set var name equals default. So, and similar to typed views and typed functions, these things are private to the session. So you can define these things and it will not collide with any other session that is running. Okay, so you can define them just locally to the notebook. At the end of the notebook, they will just automatically be destroyed. Okay. You can also explicitly drop them if you're like careful about these things. Okay, so now the next question that people say, this is great, but I really want to pass a table name as a parameter. And you just talk about literals. So how do I pass a table name as a parameter? The problem here is, there you go. It was missing the screenshot. That was weird. Okay, so if you try, for example, select star from colon table name, right? Or you use a session variable, you declare a table name names, I even backticked it just to be safe and select star from table name. None of these work, right? In one case, it gets a syntax error, and the other one it says, well, table name is not a table, I know. Well, of course it's not a table, it's a variable, but it doesn't know that. So because values are not names, and we need to teach Databricks how to do that. So, and we have done that. So you can parameterize names by using the identifier clause. Okay, it's very simple syntax, it's just identifier, and then it looks a bit like a function, but it is a clause. And then you give it a constant string. So important part is a constant string. It can't be a query that goes to the table, at least not today. But it has to be something that we can compute as we parse the query. Okay. So, and it's supported in most places where an identifier goes. So you can use it in a query for just about any column, function, table name, and the likes. or in a DML statement. You can use it as a subject for DDL statements. I use the word careful, so it's the alter table name. You can use it there, right? Or create and drop, right? And even in things like use. Here's an example. So this is an example using session variables. So we have like a table name called names, right? We have column name called name, we have function name called count, and now I'm doing select identifier, function name, identifier, column, kind of like crazy stuff. And you see here at the bottom, you also see how I combined, how I made a qualified name by actually doing a constant expression. So the column name is constant because it's a session variable. We know what it looks like when we start the statement, and then it just glued together, concatenated in a schema qualifier. Okay, and there comes the number of Anthony's out again. Okay. And the same thing, of course, works also if you were to use widgets. I don't have a screenshot for this, but you can do the same thing with widgets, with name parameter markers as well. So this is quite nice. So again, safe from SQL injection, right? So you only can get a table name in there. Okay, and with that, I pass it on to Milan.
Thank you, Serge. All right. So far, Serge has introduced many new cool SQL features and capabilities, and we all love SQL, that's why we're all here. But the feedback that we get from you basically is that even though you would like to, you still cannot use SQL exclusively. Even for simple stuff, you often end up in a situation where you have to mix and go back and forth between languages, and things become messy and ugly as stuff grows, like as your code becomes more complex. One of the main reasons why you cannot use SQL exclusively is because it's missing procedural logic. So we decided to do something about it, and that something is, of course, implementing a full-blown SQL scripting support that will follow SQL PSM standard. So what does that mean? That means that natively in SQL you will have support for regular stuff like control flow, which is if, else, and case. You will have support for looping, which is while, repeat, and iterate. Result set iterators, which will allow you to iterate over the rows of previously executed queries. Exception handling, whenever exception happens, you can define the behavior, whether you want to continue or exit. And finally, parameterized queries, which will allow you to construct queries from your current state being session variables, result of previous queries, and then pass this constructed query to execute immediate for it to be executed. So for some reason, I'm missing the QR code on the right, but also private preview is just starting, so you can sign up for it, and I hope that the picture will be at the end of the presentation visible. I'm not sure why it's not visible there. It's visible on my screen. It works on my machine. Instead of like going through the bullet points, let's actually build a real-world example together. So to set the scene, who are you? You are someone that hates spelling errors. And it just so happens that a colleague of yours thinks that you belongs in the word color, and it just so happens that you're strongly opinionated and don't think so. And it just so happens that this same colleague of yours was doing some task, created a bunch of tables whose column name is color, and you just know that he put a U there. And well, you want to get a good night's sleep, but you cannot because this U exists. So you have to do something about it, and what that something is, you're actually going to go ahead and rename all the columns that have color in it. So what is the first thing that you need to do? First thing, you need to figure out which tables do you need to alter. For this, we do a simple select query over information schema columns with a predicate on column name, and we will store results in an array. All the table names, we will store them in an array. All right, so now that we have the tables, what is the next thing that we need to do? Well, we need to consume them. We need to do something for each of these tables, so we'll just iterate. This is where we introduce the while loop. So the syntax is as you would expect it, a simple while followed by a condition and a code block that's wrapped in a do and then while. The condition can be any expression that evaluates to Boolean, of course. All right, so far so good. The next thing that we need to do something in this loop, right? But we just learned that as part of fetching the rows from information schema, we also fetch the views, and we cannot alter the views the same way we alter tables, so we need to special case the view, and this is where the control flow enters. So again, we will use if-else statement here. If syntax is again as you would expect it, if followed by a condition and a code block wrapped in and then if. All right, and the final step, we need to do the actual work. So we will construct a query by concatenating strings and pass it to execute immediate. We cannot inline the alter statement here because the table name depends on each iteration of the loop. So we have to sort of do this concatenation and pass it to execute immediate, construct the query dynamically. All right. So when we put it all together, this is what we get. But actually, we want to do a live demo here. So I won't go over here. Let's go to the notebook. So I've already pre-created 2 tables with the spelling error. So I'm both the guy that spells with you and the guy that spells without you. So, okay, so let me go back. So you can see, I hope, that there is a U over there. So this is the first table, this is the second table, obviously name _2. So if we zoom in, you can see that it also has U in it. And finally, to the fun part, we are here, this is the script. So it's a code block that begins with the begin, obviously, and ends with an end. And then we have, well, we call these parameters, these are variables, and it's important to clarify these are not the session variables, these are bound to the scope, and as soon as you exit the code block, these variables won't exist anymore. So we put them here, so we want our script to be reusable, so anyone can just change literal strings and do the renaming as well. These are just some helper variables, nothing really important. We finally come to the first step of from our presentation. And here we are doing the query over information schema. And I would like to call out here, we use this to also showcase the collations. So we don't really want to enforce anybody who's reusing our script to have to put correct casing because the identifiers are case insensitive. So we'll just use Unicode case insensitive collation here. Then a while loop, we need to fetch a table type from information schema. Then we have, and we put it into variable. And then we have if statement. We special case the view, again using Unicode collation because I don't really want to know and I don't really care how information schema stores whether it's uppercase, lowercase, mixed case. We can just delegate these to collations. And for the sake of this demo, we won't be doing the alter of actual views. This is enough to go to sleep. So we put this into variable, construct a query, and we call execute immediate. So let's actually run this. It says OK. Now let's actually prove it's OK. We go back to the tables. So there's no U. Well, letter U. And there's no U as well here. And with this, I'll give back word to Serge for summary.
Sure. So yeah, so in this talk, we talked about Lambda functions. We introduced SQL UDFs. We announced string collations, which are in private preview. We talked about name parameter markers, session variables, identifier clause. We touched on the execute immediate, which is a quite powerful statement, by the way, so there's a lot more to look at, especially once we combine it with scripting. And then Milan concluded with the SQL scripting, which is also a private preview. So yeah, it's kind of like stuff they've been up to not over the last little while, and some other things are just all these that just deserve to be pushed up again to the forefront of the mind, especially the select stars one I really like. So yeah, with that, okay. Yeah, I know. Yeah, I think we have over time. Thank you. People can catch us outside.
We can take the questions when we get out of the stage.